talk to you about real quick before we get started. Excuse me. So I sent out a remind message the other night. I've lost track of time. It could have been yesterday. I don't remember. But I sent out a remind message asking you to complete the video consent form, and probably about 5 of you have. So if you could do that for me, that would be great, because I really need to get that in. So again, it just takes about 2 or 3 minutes. No big deal. It just says that you're okay with the fact that your voice is getting recorded and getting put onto YouTube or wherever I end up uploading these things. That's all. Okay, so there's the first topic. Second topic is the exams that you guys took last week are graded, and the grades have been put in Blackboard. I've made the comments, and if you have problems, as far as what program, just put your major. Not a big deal, okay? Just put your major, no problem at all. Or on the video consent form, that is. So it's going to ask you what program you're enrolled in. Just put your, education or criminal justice or whatever your major is. Anyway, exams are graded, and they're in there, and the dog's about to bark at something. So let me know about your test if you have problems. Some of you still, for whatever reason, when you're uploading it, it's not coming in as something I can write on. And so I have to type everything, which is why it takes me so long to grade, 60 exams. It takes a while. The next thing is that we are finally moving on to the last unit for this exam, or for this class rather, and that's Unit 5. And if you've noticed, up until now, every unit has matched the chapter, so to speak, meaning Unit 1 was Chapter 1, Unit 2 was Chapter 2. We are scooching forward to Chapter 7, okay? So yeah, it's Unit 5, but it's really Chapter 7. And so if you have looked in Blackboard, I've put the whole entire Chapter 5 notes in there, just like I did for the previous units. They are filled out. But you know that I do handwriting notes every day. And so however you want to deal with the notes is your decision. But I think that's pretty much it. I think we're ready. This will be the last unit that we cover, and we're going to do, I think, 5 sections. And then on the 24th, which is next, let's see, it's 9 days from now. So I guess it's like next Friday or something like that. No, it's 11 days. That's going to be the last day of class, and that's when your last test is going to be. That's going to leave us, I'm getting to that, Sydney. That's going to leave us with 1 full week to review for the final exam. And then during that week of review, you will also be able to take your replacement exam if you choose. And so the replacement exam, I think I mentioned this just in a little bit of detail. You're going to look through your exam scores, because I'll have them all graded by then. And you're going to pick the one that you've done the worst on, or the one that leaves you with the most room for improvement. And you're going to say, hey, I'd like to retake, Unit 2 or whatever. And then I'm going to, fudge some numbers and say, hey, if you take it and you get like an 80, then that'll bump your score up. But, or on the other hand, if you take it and you have to get like 102, which obviously is impossible. So we'll talk about which exam you should retake if you should retake one. Not everybody is going to want to take a replacement exam, and that's fine. So yeah, we're going to get a whole week of review, and I'm going to come up with some activities in Hawks, some things that we can maybe look through, and of course some handwritten stuff, and we'll still keep Zooming. So I'm going to do everything I can to get you prepped for the final. So before we actually start with today's notes, if you want to type or speak up, does anybody have any questions regarding the plan for the rest of the semester? So we have these 2 weeks, this week and next, for Unit 5. Next, the 24th, which is a Friday, that's when your exam's going to be due. Then the following week is just what we call dead week. I think a lot of people call it that. We're only going to be reviewing for the final. There's not going to be any new information. It's just review. And then the following week is finals week. So any questions regarding the rest of the plan? And I've updated the schedule, and I'm going to go through and figure out when our final is going to be as far as which day. And I'll put that in there so that you know exactly which day. No, there will be no Hawks for that last week. As soon as you finish section 7.5, that's the last Hawks assignment. Now, I will put some review stuff in Hawks, but it's always optional. The review stuff will be optional. So no, Sydney, as soon as you get 7.5 done in Hawks, that's it. No more Hawks homework. All right. Any other questions before we go ahead and get started for the day?
So is our final still cumulative?
Yes, it is still going to be cumulative. Yes. How many questions on the final? I don't really know, to be honest with you. I haven't got that far with my planning. It's going to be an exam that is roughly the same length as all the other exams, but instead of it being focused on one chapter, it's just going to be everything. And typically, generally speaking, not online, not because it's online, but typically when I give a final, we always have 2 hours. You guys know that. You've taken finals before. And so even though it's a 2-hour test, that doesn't mean it's going to be 1,000 questions. Okay. It's going to be like, probably 25 or less, like a typical final would be. I'm not 100% sure yet. I haven't got that far, but again, it's not going to be an 18-page test. I swear. Okay. All right. Anything else that you guys can think of before we go ahead and get on with today's stuff?
Are you going to make a review for the final, or is it just going to be us reviewing stuff we know?
I assume, if I had to guess, that you guys want a paper review, so I'm going to make one. But we will also be just like, we'll Zoom with each other and we'll say, okay, let's focus on the questions we have from chapter 5 or whatever. It's going to kind of be up in the air about, what do you guys want? What do you guys need? There'll be reviews in Hawks. I'll come up with a paper review that I'll stick into Blackboard. I'll come up with its key. I'll put it in there as well. And then that's going to be pretty much it. Okay. Just kind of getting you guys used to what the final is going to look like and the material that maybe we're not quite sure of.
So the study guide will be very similar to the final like it has been all semester.
Yes.
Okay.
Yes, it will. All right. Anything else before we go ahead and get started with the notes? Okay. All right. So let's go ahead then and let's do that. Let me get my whiteboard up here. Okay. All right. So we're going to jump into chapter 7, and chapter 7 is actually one of my favorite chapters, mainly because once we get to it, we talk about exponential functions and we talk about exponential growth and decay. And it's one of my favorite sections because it's actually really applicable to real life. And tomorrow, when we look at banking questions and exponential growth questions, you're going to see that it is actually relevant. We talk about how you can make money when you put, money into a banking account. One of the best real life examples that I can think of right now is this virus that's going on. That grew exponentially, right? It didn't just grow at a solid rate. It was, really, really small. Then bam, it got really big. That's what an exponential function looks like. So today we are simply focusing on the first section, 7.1. Hold on, I'm having an issue here. Come on. All right. 7.1. And the chapter in the section name is exponential functions and their graphs. Okay, so what's going to happen in their graphs is we're going to start talking about a different type of function that we have never talked about. And that's called an exponential function. We've looked at a bunch of different functions. We had all those parent functions from the last section, but now we're going to have a brand new one. So we have to define that so you know what it looks like, okay? So we're going to say, let A, and I'm going to put this in little quotes because this isn't the word A, this is now the letter A, okay? Let A be a fixed, positive, real number not equal to 1. Not equal to the number 1, okay? We're going to go on to say, and I'll give you a second to write all this down, then we'll talk about it. The exponential function with base A, and again, when I use these little quotes here, it's because I'm talking about a thing, not the word, is the function, and here's what it looks like. F of x equals a to the x. This is what an exponential function is going to look like. Okay, so take a second, write it all down, then we'll talk about it. Let a be a fixed positive real number not equal to 1. The exponential function with the base a is the function f of x equals a, we read this as a to the x. Now, what's going to have to happen in this section? We're going to have to memorize just a couple things. And so in the last chapter, when we talked about our parent functions, this is another parent function, so to speak, okay? And we're going to have to memorize a few things about it. So in the last section, we memorized that all of our parent functions had the same vertex, which is 0, 0. Okay, well, you're going to see something kind of close to that in this section. And we're going to have to be able to quickly, come up in our head with what this looks like. So before we take a look at a picture, because right now you have no idea what it looks like, Are there any questions on what this first slide says? Let a be a fixed positive real number not equal to 1, and the function itself is f of x equals a to the x. This is the thing that we're focusing on. So any issues, any problems before we take a look at the pictures that we're going to have to come up with? Okay. All right, so I'm going to split the screen in half. So however you want to write this is fine. We're going to say this. The a that we just wrote, if a is greater than 1. And then we're going to say, okay, well, what if a is less than 1? These are the types of pictures and these are the types of functions that we're going to have. So if a is greater than 1, this is going to be kind of neat. If it's greater than 1, it's getting bigger, so to speak. So we're going to say that it is an increasing function. Okay, it's increasing function. We're also going to say, and I'll show you a picture in just a moment, that the y-intercept is going to be 0, 1. And the reason why that's going to be 0, 1 is because if x is 0, that gives me the number or the letter a to the 0, and we learned way back that anything to the 0 is just 1. And so we're going to memorize this. And I don't want us to have to make this little chart every time because that's a pain in the butt, and I don't have time for that. So here's what I need to memorize. It's an increasing function. Its y-intercept is 0, 1, and here's what it's going to look like, roughly. You're going to come up to 0, 1, you're going to draw a dot, and it's going to look something like this. It's getting very, very close to that x-axis, but it's never crossing it. How many of us have seen a function that looks like this before? Anybody?
Yes.
Okay. So this is what we call an exponential function. Okay, so some of us have. Okay, good. Hold on. I've hit the wrong button, and now my mouse isn't doing what it's supposed to do. So give me just a sec. All right. There we go. Trying to look at the chat. Okay. So people are just saying that, yes, they've seen it. Great. Okay, so that's the first thing that we're going to have to memorize is just what that looks like. And so eventually what's going to happen is this little a that's out front and out in the front of my function, it's not always going to be a letter, obviously. It's going to be a number. And anytime that a number is greater than 1, then what I know is in my mind, the intercept is 0, 1, and it's going to be an increasing function. Meaning, as my eyeballs go from left to right, this thing is going up. Okay, we talked about increasing in the last section. That isn't going anywhere. Now, on the other hand, if a is less than 1, we have to know this. It is a decreasing function. Okay, and the y-intercept in this particular instance is still 0, 1. And so here's what a decreasing function is going to look like. You're going to come up to 0, 1. You're going to put your dot, and instead of it going up from left to right, now it's going down from left to right. So it's going to look something like that. All right, now, this is what you have to know. So looking at these two pictures, what are your thoughts right now? Because we're going to manipulate these graphs just like we did in the last section. We're going to move them, flip them, make them big and make them small, all kinds of things. So any questions on the way that these little guys look right now? Okay, hold on. I see a question coming in. Oh, no. Okay. All right, so now the next thing I want to write, and I'm putting it in red and I'm putting a star beside of it. We're going to say that the y-intercept of any parent exponential function, and I'm going to shorten this to just expo because I get real tired of having to write exponential all the time. So any parent exponential function is the point 0, 1. We need to know that. So no matter what the function I'm given, and we're about to look at an example that has real numbers and not just a bunch of, this is what it looks like. Any parent function, no matter what it does look like, I always am going to start out by saying that my y-intercept is 0, 1. Based on that y-intercept and based on the fact if I'm going up, down, left, right, anything like that, that's going to tell me where to move. Okay, now there's just a few more things I need to tell you, and then we're going to do it, okay, so that you can see what's happening. Because otherwise, this is just a bunch of nonsense. Doesn't make any sense.
What does it say after expo function?
This says, is the point 0, 1.
Okay, thank you.
Sure, absolutely. All All right, I'll give you one more second to write this down. If you have any questions, ask them now, please, so that we can go ahead and take a look at the next thing that we need to know. Okay. All right, so I have one more important thing to tell you, and then we're going to look at what happens when we do transformations, and then we're going to do it. So here we go. Now, in the last section, we had to make that X and Y chart, and we had to pick a bunch of different numbers. And sometimes we picked numbers that were really close to the vertex, and sometimes we didn't. And, there's a bunch of rules. Well, here's what we're going to do for these exponential functions, okay? And you're going to like this because it's very straightforward. When we go to graph these things, if it's not super apparent what it's going to look like, we are going to, we're going to, whoops, hold on. We're going to say that using x equals -1, x equals 0, and x equals a positive 1 in our x, y chart, this will produce a good idea of the shape of the graph, which is what we need. So when we make our XY chart, we're going to just choose these three numbers every time. Now, what's going to happen is we're going to be looking for transformations. Just like we did, just like we did in the last section, okay? And a lot of them are going to be the same. So what's going to happen is we're going to be given this function, and it's going to look like this. F of x equals. Now, there could be a negative sign out front. There's going to be some number, and then there's going to be an exponent in which there could be a negative x. There could be a minus h. And on the back, there could be that big plus k, just like there was in the last section. And so we have to think back to last time, and we have to say, okay, well, a lot of the rules that applied in the last section still apply today. And so we had said way back that if there was a negative sign at the very beginning of our function, what does this indicate? Does anybody remember what this tells me I'm going to have to do?
I want to say a y-axis.
Oh, you're so close. It's an x-axis reflection. And what that means is if something looks like this, it's going to look like that. I'm just flipping it over the x-axis. And so that negative sign, if there is one, it still means the x-axis reflection just like it did. Okay, now this one was in the last section. We didn't see this very often, but we said it could happen. If we saw a negative sign directly in front of the x that was inside our parentheses, we did not see this very often, but what did we say this meant?
Y-axis reflection.
And so that means if something looked like this, I would flip it over the y-axis and now it looks like that. And we're going to see much more y-axis reflections in this semester, in this section than we did in the last. Okay, so then the next thing I see is this h value. And so just like last time, since it's on the inside, if we see a negative h, that means which direction am I going?
Right.
Right. And if I see a plus h, then I'm going left. And then lastly, if I see this k, if it's a plus k, which direction am I going? Up. If it's minus k, well, then I'm going down. So all of these transformations still hold true, okay? And we're going to see all kinds of graphs given to us in different ways. And based on these transformations, we are going to have to use these values up here to make our x and y chart and then graph this thing. So take a sec, look at this slide before I move on, and ask me your questions. We're going to choose -1, 0, and 1 every time. And all these little guys that are down here, these tell me how my graph will be situated when I'm done. So any questions, any problems on that? Okay, so then let's take a look at a first real example so that you can see what the heck I'm talking about, okay? So here we go. Example 1. If you have f of x equals 3 to the x, and I say to you, hey, I need you to graph this exponential function, okay? What do you think we should do?
Make an XY chart.
Absolutely. Now, before we make an XY chart, okay, I'm going to show you guys some tricks and some tips that I want you to do so that this is easier, okay? So the first thing that we're going to do before we do anything else is we're going to look at A, which is the number. A is always the number. And we're going to write a few things down. We're going to say in this case that A equals 3. And then if you think back to the very first picture that we drew, we said if A was greater than 1, something happens, and if A is less than 1, something happens. So the number 3, is it less than 1 or greater than 1?
Greater.
Okay, so watch what I'm going to do. I'm going to say, oh, 3 is greater than 1. And because this number is greater than 1, before I draw anything, I need to know, is this going to be an increasing or a decreasing function?
Increasing.
Okay, and this comes straight from my notes. INC. So this is an increasing function, which means, what's the y-intercept of any parent function?
0, 1.
0, 1. And so in our mind, we already know before we do anything else that at 0, 1, I'm going to have a dot and that it should look something like this. So remember way back when we said, oh, if I give you the absolute value of x, you should be able to conjure up in your brain that it's a v. Remember us how I pounded that into your head, or at least I tried, whoopsie, or at least I tried to? It's the same thing here, okay? It's a brand new function. It's a new parent function. And so now what we're going to have to do is we're going to have to take a look and we're going to have to ask ourselves, anything happening out front here? No. Anything happening inside this x? Well, no, there is no inside, so nothing's happening. Anything added or subtracted to the back? No. And so what that means is no transformations are happening. So maybe we jot that down. No transformations. It's just this guy as he is. And so then what's going to happen is we're going to make our XY chart, just like you said. And according to our notes, what are the x values that we are supposed to pick each time?
-1, 0, and 1.
Yeah. And so then what's going to happen is we're going to come over here and do some work. We're going to say, okay, 3 to the -1 equals something, 3 to the 0 equals something, and 3 to the +1 equals something. Does anybody remember when we have negative exponents? We're not supposed to. So what do we do? Because we can't have it like that.
Make it a fraction.
Yeah. And so I put that over, I put 1 over 3. And since this is just to the first power, this is just 3 to the first down there, so it doesn't really do anything. And so the point that I'm going to graph is -1, 1/3. Okay, next, 3 to the 0. Any number to the 0 is always what?
0.
Nope. 3 to the
1.
yes, it's 1. So the point I'm going to have is 0, 1. And then 3 to the first power is just the number 3.
3.
And so now I have 1, 2, 3 points. And so I'll draw my little graph over here. Okay. All right, looks good. And I'm going to say, okay, well, the first point I have to graph is -1, 1/3. So I'm going to scooch over 1. I'm going to go up just a little bit to 1/3. And I'm going to say, okay, well, the y-intercept, guess what? I already knew that should be on there because I told myself it should. So I graph the y-intercept of 0, 1. And then the next point is 1, 3. And so I go over 1 and I go up 3. Now, I know that it's tempting to just go boop and draw a line because that line almost hits all 3 of them. But because this is an exponential function, I know it's supposed to curve in this manner. And so here's where it gets just a little, you got to be kind of precise in your drilling. This guy has to kind of cut up sharply, and this guy does not cross the x-axis. It gets real, real close, but it doesn't cross it. And then I'm done. This is my total and complete and final answer. So take a sec, take all this in, ask your questions, let me know what you think. Any questions with this? So my advice is this. Look at your problem first, obviously. Write this stuff down, okay? It might take an extra 30 seconds, but it's going to be worth it in the end. And the reason why I'm telling you this is because when you go to Hawks, which I'll show you some problems like that, Hawks doesn't even make you make an X and Y chart. I'm just doing that so you understand why. Hawks just wants to say, hey, draw me a rough graph, a rough draft graph. Ooh, that's hard to say. So in Hawks, you don't have to do all of this work, but you have to be able to picture in your mind what it's going to look like. So any questions on number 1? Okay, so let's take a look then at the second one. We're going to use the same problem that we had, but we're going to make it have a transformation so that you can see what it looks like, okay? So we're going to have f of x equals, let's say -3x plus 1. So here's what I'm given, and guess what? I have to go ahead and graph this thing. Well, the first thing I want to do before I do anything else is find my a. And remember, it's just the number. Whether or not it's negative is irrelevant. In this case, I'm going to write that a is equal to 3. And then I'm going to say, okay, is 3 greater than or less than 1? Well, it's greater than. And since it's greater than, I know it's an increasing function, and so I know it's going to have to be going up like that. I also know, before I do anything to it, before any transformations happen, that the y-intercept is, again, 0, 1. Okay, now I go and I look to see what's happening. In the front, I see a negative sign. So this negative sign tells me what? Since it's at the front of the whole
X-axis reflection.
Yes, so x-axis reflection. Whoops, REF, okay. Oh, that looks terrible. It's an x-axis reflection. And so then I look, reflection. I look and I also see a big old +1 out here. And so that +1 tells me that I'm going up 1. So here are my, here's my information. And so what I'm going to do is I'm going to go ahead and make my XY chart. So I'll do that over here, x comma y. And again, what are the values that I'm supposed to pick every time? -1, 0, and 1. And then I'm going to say, okay, well, over here I have to do the work. So I'm going to have -3 to the -1 plus 1. Now, you're probably going to need your calculator for this, okay? So what's going to happen is, remember, this negative sign and this 3 are two different pieces. So really, you're only raising the number 3 to the -1 first. So if this is your calculator, here's how I would type it in. Negative sign, parenthesis, the number 3, close parenthesis, raise it up to the -1, come down using an arrow button or whatever, and press +1. But regardless, however you do that, what's going to happen is you're going to get, eventually you're going to get -1/3 plus 1, and when you actually do the addition, you're going to get 2/3. We're going to see a lot of little fractions, a lot of thirds in this type of problem, a lot of halves. Okay, so we got to get used to using our calculator to do that. Okay, so we already know, we don't have to do this work. We already know that the intercept is going to be, oops, hold on, drop my pen. We already know that the intercept is supposed to be 0, 1. But since we have transformations, we can't just slap a 1 in here. Okay, we actually have to do it. So we're going to say, all right, well, -3 to the first, to the 0 power and plus a 1. Well, what is 3 to the 0? Just 1. And this negative sign comes down. And what's -1 plus 1?
0.
Okay. And so now I have 0, 0. And then lastly, I have to plug a positive 1 in there. So I'm going to have the opposite of 3 to the first plus 1. Well, what is 3 to the first? It's just 3. This negative sign comes down. And then I add 1 to that. And what is -3 plus 1? Going to be -2. So take a sec, look at the work that we've done. This isn't really new necessarily. We've been plugging in things forever now. So any questions on how I got these three numbers? 2/3, 0, and -2. Any questions on that at all? Okay. And so now that I have that information, I'm ready to graph this thing. And so I'm only going to have to graph these 3 points. And so I'll make my graph here. Okay. And so I plot the point -1, 2/3. So I go over -1. I'll do a different color so you can see it. I go over to the -1 to the left, and I go up 2/3, which is, 66.6% of the way. So up more than half. And then I have the point 0, 0. And then I have the point 1, -2. Now, these 3 lines does not look like to me that this is a graph is going up. It looks to me like this graph is now going down. It looks to me like it's decreasing. Well, that it is. So we got to talk about this, okay? Because I know that these two graphs don't look the same. So here's what I want you to think about for just a second, okay? I'm going to use a bright orange so you can see this. If I plot the y-intercept, which is the point 0, 1, so right there, and I know that it should be going up, so it looks something like this. All right, now bear with me. If I were to do an x-axis reflection first, because that's the first transformation, and I'll do this in purple so you can see it. If I were to just take the orange line and x-axis reflect it, well, this is the x-axis. So what would happen is this dot that is at 0, 1 is now going to be at 0, -1, because remember, they mirror each other. And the fact that this guy's going up and, just as an increasing function, well, what's going to have to happen is it turns into a decreasing function, because again, if I could fold it right here, just like your palms match, this orange and this purple function would have to touch each other perfectly. And then if I apply the last if transformation, which means up 1, this guy right here, that is at 0, -1, is going to up to 0, 0. And he's still going down. And so if you look, the pink line, which is just covering my green, is my final answer. So let me get rid of all this junk, and you tell me what you think. So we made our X and Y chart. Whoops, we graphed those 3 lines, and we connected them, and now we're done. Now, what do you think? Questions, problems, issues?
In the test, are you going to want to see us write all of the stuff to the right in the little box?
On some of them, yes, and it'll be very clear which ones, because we don't know this yet, but in like 2 sections, we're going to be doing the inverse of these, which is going to be just a different ball game. And so today, no, but in 3 days, yes. Okay, so
Okay.
you will know when you have to do it. Okay, you will absolutely know. All right, any other questions right now on this number 2? All right, so now here's what I want to do next then, okay? That's a lot of work. And, you know, I'm kind of lazy sometimes. I don't want to do all of that. So here's what we're going to write, okay? Our goal for you in this class is to be able to draw a rough draft without a lot of work. Okay, that's the goal. I mean, I'm just being very blunt with you. That's what we're trying to do. Okay, because I don't have time to draw 40,000 XY charts. I don't want to have to do that. Okay, to do that, here's some things that we have to know. To do that, we must know just a couple things, which we've talked about already. The y-intercept of expo parent function is 0, 1. The second thing, if a is greater than 1, it's increasing, which means going to look something like this somewhere on that graph. The third thing is if a is less than 1, it's decreasing, which means it's going to look something like this. We also have to keep in mind those transformations. The order that we would be applying our transformations is horizontal. Remember, think back to Hawks. Remember when you had to fill in all those boxes? They ask you, hey, does this have a horizontal shift? Yes or no? The next one was stretch. Well, these ones don't have stretchers or compressors, so we don't have to worry about it. The next one is x-axis. The next one is y-axis. So 1, 2, 3, and then the fourth one is going to be vertical. This is what we have to look for, okay? And if they have these transformations, if they are shifted left, right, up, or down, that comes, no, if they shifted left or right, that comes first. We have to apply that first. Then we would have to apply the fact that there's an x-axis reflection, then a y-axis reflection, and then lastly, if it's vertical, shift up or down. And I'll show you what all this means when we go to do a problem. This screen right here, these 4 things, I need you really, really, really to know them, okay? Because this is what's going to get us through this, graphing these. Because again, I don't want to have to make an X and Y chart. When you see the problem that we're about to do, the X and Y chart would be a nightmare. So I don't want to do it. So what are your thoughts about this list? The y-intercept of the parent function is 0, 1. If a is greater than 1, it's increasing. Looks something like this somewhere along the line. Number 3, if it's less than 1, it's decreasing. And the transformations. Any questions, any problems? Because now we're about to just dive right in and do some of these examples without having to do a ton of work, because that's too much work.
What's the third transformation? I can't see it. The
Y-axis. Sorry.
y-axis.
Yeah, y-axis. I can put it over here. All right. Anything else before we scooch on over to the next one? Because finally, after all this yammer on, we're going to do a problem. All right, so here we go. I'm not sure where we left off, but I'm just going to call this 1. I don't know. Okay, so we're going to say h of x equals 7/2 to the x. All right, now, again, if you had to make an XY chart here, look how bad those numbers would be, right? It's already a fraction. They'd just be even worse. And so we're going to get lazy, and we're not going to do that. So here's the trick. First thing is always, we're going to say a equals, what is my a value? It's just 7/2. Now, generally speaking, is the number 7/2 greater than 1 or less than 1? What do you
Less
think?
than.
Okay, I'm glad you said that. Usually, when we see a fraction, everyone thinks a fraction is less than 1. But if you remember, when we have a fraction, it's just divided by. So this just says 7 divided by 2. Well, is the answer to this going to be a number that's bigger than 1 or going to be smaller than 1?
Bigger than one.
Bigger.
Bigger. So that's why we can't just say if it's a fraction. We have to say if it's bigger or smaller than 1. So in this case, 7/2 is greater than 1. And so because it's greater than 1, I know that it's an increasing function. And then I also know that before any transformations happen, its intercept is 0, 1. Well, I look back at my problem. I'm looking only at this. In this box, are there any transformations happening? Is anything getting, up, down, left, right, or flipped around any axis? Any transformations happening?
No.
No. And so maybe we jot down no transformations. And so what's going to happen is because there are no transformations, this little guy doesn't change at all. And so I'm going to come over here and I'm going to put my point at 0, 1. You told me it's an increasing function. Okay, now I'm done. That's how easy we're going to make this. Okay, now of course this has arrows, and this is the point 0, 1, and now we're finished. Now, what's going to happen in Hawks, I'm prepping you for Hawks as always, is they're going to give you 4 or 5 graphs, I can't remember how many, and you're going to have to choose. So maybe one function looks like this, and then maybe this one happens to have the right answer, and then maybe this one, looks like this, and maybe this one looks like that. I don't know, okay? What's going to happen is you are going to have to be able to write this down on your paper and say, oh, because there are no transformation, it definitely looks like this. It still goes through the point 0, 1, and then you're going to have to come over to each of these and say, oh, look, doesn't go through the point 0, 1, it's not increasing. Doesn't go through the point 0, 1, not increasing. No. Oh, hey, look, and you're going to have to pick the right answer. So now, if this were Hawks, you would write this down on your paper. You would click the right graph in Hawks, and they say, "Good job," and then they'd move on to the next one. So, what are your thoughts on 1 right now?
So all Hawks is just picking the right graph.
Yep.
Okay.
And if you were in the practice section, you could pick until you got it right, but you can't do that in the certify section, right? And obviously, I don't want you to just guess your way through anyway, but we have to understand how to do this without having to put a ton of work in. I didn't have to make any X and Y chart at all.
So if there's no transformation, you don't have to make an X and Y chart.
Even if there is a transformation, we're still not going to make an X and Y chart. Okay? So let me show you what happens when there is a transformation so that we don't have to make it. So here we go. Let's do number 2. Okay? So number 2, the problem is going to be g of x equals 1/5 to the negative x. Okay, so the first thing we have to do is we have to say, okay, a equals 1/5. And then I say to myself, is 1/5 greater than 1 or less than 1? It's less than 1. And because it's less than 1, this is going to be a decreasing function, which in my mind, I know means looks something like that. And before I do any transformations, my y-intercept is 0, 1. And then I look over here at my actual piece, right here in this box, and I say, okay, well, do I see any transformations happening? The answer to that is yes. Okay, and here it is. And so since there's a negative in front of the x, what is happening?
Y-axis.
Yeah, a y-axis reflection. And so we know that if we reflect something, if something is over here and I reflect it over the y-axis, it now is over here. And so what's going to happen is I know, okay, I know that my function should look something like this. Oh my goodness gracious. I know that it should look something like that. And so I could very quickly just sketch what it could look like. Okay, I'm making a dotted line because this is not my final answer. This is my parent function. Well, if I'm picking this thing up and I'm just flipping it over the y-axis, is this point changing? Is the 0, 1 changing? No. So what's going to happen is the points that, well, hold on. You guys got to keep me on my toes here. I made the wrong type of graph to start with. All right, let me try it again. It's been a long week, and it's only, what, Monday? 0, 1. So it should look like this. I drew it the wrong way. My apologies. Okay, so there's what it should look like, just the parent function. Now, I'm applying this transformation, which, again, we know is a y-axis reflection. Here's my y-axis. You know this point's not going to change. So essentially what I'm doing is I'm picking this guy up, and I'm scooching it over here. And I'm picking this teeny tiny piece up, and I'm scooching it over here. So having said that, what's going to happen is this, and the black dotted line and the red line are mirror images of each other. And without having to do a whole lot of work, here's my answer, the red line. Done. And so again, in Hawks, you're going to look for the red line on your graph, and that's what you're going to pick. The black line is just what the parent function looks like before any transformations happen. Now, what are our thoughts about this? So this is why it's so important for us to know what the y-intercept is, what a is if it's greater than or less than, and what the transformations mean. And again, no, I didn't even touch a calculator. I didn't do any work hardly. So what do you think?
So for the fraction part, though, if we needed to see if it was greater or less, then you would just divide out the numbers.
Yeah.
Okay.
All right. Any other questions on 2? So this was our first one that had a transformation. It was just a y-axis reflection, and now we're done. All right. So let's take a look at one that has a horizontal shift, because we haven't seen one like that yet. And so what if I have f of x equals, and this one looks nasty, 11/4 times x to the negative 1. Okay, well, as always, we start out by saying a equals, and in this case it's 11/4. And so then is 11/4 greater than 1 or less than 1? Greater, okay. And so because it's greater than 1, I know this is going to be an increasing function, so it has to look something like this. And before I do any transformations, I know that my y-intercept is 0, 1. And so then I say, okay, I'm ready to look for transformations. Are there any transformations happening in this function? This guy. And so because of that negative 1, which direction am I moving?
Aren't you moving to the right?
Yeah. And so watch what's about to happen. Okay, here is my graph initially. Here's my 0, 1. Here's my increasing in function. And again, I'm dotting it in here. And so the only transformation that's happening is right 1. And I spelled right wrong. Can you believe it? Sure. And so what's going to happen is we're going to do 2 things just to make sure this makes sense. HT. If I were at the point 0, 1 and I moved right 1, the new point that I'm going to have is the point 1, 1. And so at the point 1, 1, I'm just literally scooching it over 1. And I draw my line because no other transformations are happening. And so again, in Hawks, this is the point 1, 1. And so in Hawks, you're looking for a graph that is increasing while going through the point 1, 1. And that's it. I'm done. What do you think? All right. So let's then take a look at one. Let's see. Let's take a look at one that has several transformations, just so you can see, what's going to happen. All right, because not always do they just have one. Sometimes they have maybe more than one. So let's take a look, and then we'll move on to the next topic. And you can ask your questions, if you need to. I think this is 4. All right. So what if I have f of x equals 1 plus 1/5 to the 4 minus x? Oh boy, this looks rough. Okay. Well, if you had to tell me what would you do first, because this looks bad, what would you do? How would you make this look any better at all?
Couldn't you make
what
it
A is.
negative x? Oh,
Okay, so someone said make it negative x.
negative x plus 4.
Yes. Okay, so we're gonna do that, and then I think I heard somebody else kind of saying something. What did I think it was Kirsten? What did you say?
Yeah, I just said find what A is.
Okay, so both of you are right, okay? We do have to find what A is, and we absolutely have to rewrite this thing. So here's my advice, and it's not my advice, it's me telling you, please do this, okay? Here's what we're going to do. We're going to say, man, this looks rough, and I don't like the way it looks, and so we're going to rewrite the whole darn thing. Now, generally speaking, when we looked at the transformation page, here's where we had, here's what we were given, really. Our A value always came first. Any whole numbers always came last. In the exponent part, the x value always came first. So we need to make our problem look like this. And so the piece that contains the x is the A. So we're going to rewrite this as 1/5. Let me get that a little bit neater. We're going to rewrite this as 1/5. And then someone, I think it was Sophie, said, let's make this x come first. Well, the x is already negative, so it's going to have to stay negative. But that's okay. I'm allowed to do that. And this is a positive 4, so let's put plus 4. And we've taken care of all of this. And oh, look, this is a positive 1, so plus 1. Now, doesn't that at least look like something that I'm more familiar with? Doesn't necessarily look any better as far as what I have to do, because there's a lot. But this is what my function looks like. So I can just get rid of all this nastiness, because that was bad, right? And everything's out of order, and it's confusing. And so now we'll just say, well, I fixed it. And we'll just say that f of x equals all of this. Okay, so we did that. So now we have to find a. Any issues on rewriting it? Because that's going to be one of the most important things you do. All right, so what is the a value here?
1/5.
1/5. And is 1/5 greater than or less than 1?
Less than?
Are you sure?
No.
Would you rather have a whole candy bar or 1/5 of a candy bar? I'd rather have a whole Snickers. Oh my gosh, look, I listened to you when I wrote it. 1/5 is less than 1, okay? And so because it is less than 1, I know, oh goodness, the phone is ringing. Give me 1 second here. Sorry about that. I thought I turned that down. Okay, so anyway, since 1/5 is less than 1, I know this is going to be a decreasing function, and so that means it's going to look something like this, okay, from the get-go. And before any transformations happen, I know the y-intercept is 0, 1. Now, I have to look over here, and I have to list out the transformations that are actually happening. And so back on that page where I said these are the 4 things we have to know, in there, I had mentioned the way that the transformation should happen. The first transformation we need to look for is left or right. So is this function being moved left or right at all?
Left.
Yeah. So this is going to tell me left 4. Okay. Then the next transformation that I was to be looking for was in x-axis reflection. Is there an x-axis reflection here? Is there a number out here?
No.
Is there a negative sign out here? No. So there's no x-axis reflection. Okay. The next one then was a y-axis reflection.
Yes.
Yeah. So this little negative right here tells me that there is a y-axis reflection. And then the last one that we looked for was a vertical shift of up or down, which this guy tells me that I'm going
Up 1.
up 1. Okay, so now we're going to draw a real quick graph here, just so we can kind of see what's going on. And again, the one in black is my parent function. Here's my 0, 1. I said it should be decreasing, so it would look something like this. And at that particular point, this is 0, 1. Okay, well, if I take the point 0, 1 and I move left 4, what's that new point?
4, 1.
Pardon me?
Negative 4, 1.
Exactly, yeah, negative 4, 1. Okay, now, so negative 4, 1 somewhere over here, I guess. Now, if I take the point negative 4, 1 and I y-axis reflect it, well, that means that I'm going to reflect it over this line. So this is the point negative 4, 1. And so if I pick it up and I scooch it over here, what's this point? Because remember, I'm reflecting it over the y-axis. Well, that's positive 4, 1, right? Does everyone agree to that? That it's positive 4, 1? Okay, so there's that. Now, if I have to go up 1, and I'm at 4, 1, and I move up 1, what's this point? Well, that's 4, 2. Okay, so now I know where my point's going to be. The point that I'm going to draw my line through, it's 4, 2. But I got to know what my graph has to look like. So I'm going to have to go back and say, okay, well, it was supposed to be decreasing, which was black. And then I moved it over. In red, I moved it over 4, but I didn't change it, so it was still decreasing. Okay, great. But, and I should have done this in green, when I did my my y-axis reflection, sure, I moved it over here, but then what happened was my line actually is going to change the directions. And it's going to look something like that. And so then if I moved it up 2, it's still going to be a line that is now increasing, but it's going through the point 4, 2. And so in my answer, what I'm looking for is blue line. So let me get rid of all this stuff, okay, all the other stuff that we've written, so that you can have a better visual of this. Okay, this green line the best I can. And so now, oops, here's my final answer, this blue line and the 0.42. And so you would look in Hawks, and you would find a function that was increasing, and that was going through the 0.42, and now you're done. And again, you're going to see, sure, I did a little bit of work, but I didn't have to touch a calculator. I didn't have to draw an XY chart. I didn't have to do any of that. What are your thoughts on 4? Because now I'm done with graph section for now. I can always backtrack if I need to, but I don't want to right now. I want to move on. So any questions on this one?
When we're picking the right graph, the only point we're worried about is the like 4-2 point. Like we're not worried about the 0-1. Like
Right, because what's going to happen is this 0-1 is no longer there, and this black line is no longer there, because what I've done is I've transformed it. Okay? And so what I'm looking for, if you're looking to try to actually graph this thing, yeah, you're going to say, okay, I know that the A point, the line has to go through this particular point. So on Hawks, what you're going to do is they're going to have the little tick marks, you know, like we typically do. And at 4-2, so right here is going to be a point. They're not going to tell you that that's the point 4-2. You're going to have to count, and then it's just going to increase, and it's going to look just something like that, okay? And so you're going to be looking, and maybe the other graph looks like this. Maybe it's the point 2-2. I don't know. And you're like, oh boy, it could be this or this. This is where it comes down to you having to count and say, I need 4-2. So it's definitely not this guy. Oh, hey, look, here's the 4-2 guy. So yeah, this point right here is like the thing that we have to have.
Okay.
I don't care about any of these points, okay? I don't really care what they are. I just care that they're increasing. But this guy is where it's at. Okay? All right, so I would like to move on from the graphing for right now and talk to us about the second and the last topic in this section. There's only 2 topics in this. The first one's graphing. The second one is solving equations. So let's do that, and then if we need to, we can backtrack. I just want to make sure everyone gets exposure to everything before anyone has to go. Okay, so the next topic is going to be solving elementary expo, and I'm just going to continue to use the word expo, equations. So we're going to be given exponential equations, and we are trying to solve them. Well, here's what we need, okay, because again, these are going to look different than you've ever seen. So we need something that looks like this. A to the x equals a to the b. Basically, we need 2 sides of the equation to have the same base. So a is the expo base. Okay, we need that to be the same. And it cannot equal 0, because if it's 0, we don't even have a problem. And b is the constant. Okay, and I know this looks weird because, again, you've never seen things like this before. We've probably not seen, I gotta make sure, up here where this a to the b, make sure that you have a b right there, not a 6. You know my writing, and sometimes it looks like a 6. This is the stuff that we have to have. And so here's what's going to have to happen. We're going to have some equations, and I'm just making this up. We're going to have some stuff. It's going to be raised to an exponent. Let's say 4x. I don't know. And then it's going to be equal to some other stuff, and that might be like 3x plus 2. Our goal is to make whatever this stuff is, the base, we want it to become the same. However, we have to do that. Okay, we'll have to do a little bit of work. We want it to become the same. Well, once it is the same, which is where the hard work might sometimes be, once it is the same, do you agree that if I had 3 to the 3rd, that would equal 3 to the 3rd? Do you agree that that's a true statement?
Yeah.
Sure. What if I had 3 to the 8th? Do you agree that that's equal to 3 to the 8th? Yeah. So if these guys are the same number, whatever they are, that means that these 2 pieces have to be equal to each other. And so once I get rid of my base, I get to bring my exponents down and just say, hey, guess what, guys? 4x equals 3x plus 2. And then don't you guys know, like, really, really well how to solve problems that look like this? Yeah. And so what's going to happen is, right here, this part is where we're going to have, we're going to put most of our work. It's getting our bases to be the same. As soon as we get that, you're smooth sailing. So let me show you and let me tell you how we're going to do that, okay? Because you don't know, because we've never done it. So a couple steps, so to speak. So to solve, here's what we need to do, okay? Step number 1, we need to isolate the exponential term by getting it alone. Well, we've done that. We've isolated things before. Let's go ahead and put on one side so we know what you mean. Alone on one side of equals. That'll make it a little bit better. Okay, so that's step one. We need to isolate the exponential term by getting it alone on one side of the equal sign. Okay, step number two. We need to find a base that can be used. I think you guys are actually going to like these types of problems once you see it, because it's kind of neat. To rewrite both, and this is important, it has to be both. It can't just be one, because that doesn't do us any good. Both sides of the equation. Okay, and then once we do that, step number three is just to equate the powers, which just means set them equal to each other and solve. Equate the powers, and maybe down here I'll put set equal and solve, and that's it. Okay, so read through this, take a sec, make sure you get it written down, and then we'll do it. And then once we do it, these words will make more sense. So we're going to isolate the exponential term by getting it alone on one side of the equals. We might have to add, subtract, multiply, divide. I don't know yet. Step two, we need to find a base that can be used to rewrite both sides of the equation. Step three, equate the powers, which just means set equal, and solve. Any questions right now on what this just says? Because we're about to go and we're about to do it. Okay, am I good to move on, or do we need a few more minutes to write?
I'm good. I'm good.
Okay. All right. I don't hear or see any protests, so we will go ahead and we will just try a problem, and we'll see what you think. So, if I have 5 to the x equals 125, my goal in all of this is to say x equals some number. Well, generally, okay, we've never seen the variable having been in the exponent. Typically, we see something that looks like this: 5x equals 125, where 5 and x are being multiplied. Well, that is no longer the case. Now, 5 is being raised to a power. So here's the thing: you can't just type this into your calculator. Okay, there have been some equations that we could do that with. This is not one of those. Now, according to the notes, previous page, step one is to isolate the exponential term on one side of the equal sign. Well, the exponential term is just the guy that has the x in the exponent. That's it. And so this exponential term is already by himself. So step one in this particular case is done. Now, step two says we need to find a base that can be used to rewrite both sides of the equation. Well, over here, my base is 5, right? Because it's 5 being raised to something. When I just have a number, 125, what's its exponent? What's it being raised to?
Nothing.
Well, technically the first power, okay? And so over here, my base is 5, and over here, my base is 125. Now, the number 5, I cannot break it down any further, meaning there's no number that if I raise it to a power gives me 5. It's just not going to work. So I can't mess with that base. So what is going to happen is I'm going to leave 5 as my base. And I'm going to say, hey, you know what would be super great is if I could somehow take this 125 and turn it into base 5. Okay, so for the time being, 5 to the x is going to stay the same. Now, what I'm saying is this. I need the number 5 raised to some power, if possible, and equals 125. Can I do this? That's what I'm trying to figure out. So probably you're going to need your calculator. And I'm not saying 5 times 5. I'm asking myself, what number do I have to raise 5 to? And so maybe you're not sure at all, and you start with 5 to the third. Pardon me, I didn't mean to cut you off. Go ahead.
Is it 3?
It is 3.
5 to the third?
Yeah, because that means 5 times 5, which is 25, times another 5 is 125. So now what I'm going to do is I'm going to take this number 125, and I'm going to rewrite it as 5 base 3. So 5 to the third. All right, now, the second thing, or the third thing rather, step 3 is to equate the powers and solve. Well, do you agree that this number and this number, are these the same bases? Are they the same?
Mm-hmm.
Yeah, okay. And so what gets to happen is, you know what? Don't care about you, don't care about you. And I bring down the exponents. This is where it says equate the powers and solve. That just means take this guy, whatever he looks like, and take this guy, whatever he looks like, and set them equal to each other. In this particular problem, this is actually my answer. I don't have to go any further. Okay. So, hold on. I made a mistake on my notes. Big surprise. I got to fix them. Okay, and so now I'm done. The answer is 3. And so what this means, whatever value you get for x, if you were to plug it back in, do you agree that 5 to the third equals 125? Well, yes, because we already did it right above. And so when this is all said and done, let's say this was the exam, here's the work that I would expect to see, just to kind of get you in the groove of what you're doing. I would expect to see the problem, obviously, this middle step, and then an answer. So this first one is done. Number 1 is done. I'm going to leave it up, and we're going to do number 2 on the same slide, just so you have something to look at. But what are your thoughts on number 1? Any issues, any problems right now with number 1?
Seems pretty straightforward.
Yeah, it's not too bad. So let's take a look at the next one. And I'll leave this up so you can take a look at it. Okay. So if I have 3 to the 2x minus 1, and that's going to be equal to the number 27. And again, my goal is to get this teeny tiny x all by itself. Well, first thing I got to try to do is I got to look for the bases. Here's the base 3, here's the base 27. They're not the same. I have to somehow make them the same. Well, the number 3 I cannot break down any further. So this guy is going to stay 3 to the 2x minus 1. Now, it would be really great if I could somehow take the number 27, take the number 3 rather, raise it to some power and get 27. Is that possible?
Yeah.
Yeah.
So let's say we're not sure. Okay, maybe in our calculator we try 3 squared. We don't know. Well, we get 9. Well, then we try 3 cubed. Oh, we get 27. Okay, we get to stop. And so really what's going to happen is this number 27 is going to be rewritten as 3 to the third. All right, any issues with that so far? Okay, so now what's going to happen next is we say, all right, well, look, these bases, they're exactly the same. This is a 3 and this is a 3. So guess what? Don't care about you, don't care about you, because you're exactly the same. And so then I take these powers and I say, you know what that means is 2x minus 1 equals 3. And then this is the new equation that I solve. And this is easy. We've been doing this. So we add 1 to both sides. And that gives me 2x equals 4. I divide by 2. X is equal to the number 2. And now I'm done. And now you don't have to plug these back in. I'm never asking you to plug them back in. That's just if you want to check yourself, fine. If not, fine. Don't do it. But here's my answer, and now I'm done. What are your thoughts? 1 and 2.
I kind of like these problems.
Yeah, I like them a lot. I really do like them a lot. Easy. Okay.
Be problems where the bases are different numbers.
Yes, and that is exactly coming right now. Okay.
Okay.
All right. Number 3. So let's say we have 9 to the 2x minus 5, and that equals 27 to the x minus 2. And we say, the bases are not the same. And okay, let me pause for a second. This is kind of a side note. This is a side note over here. What you guys are going to have to think of and be able to kind of quickly determine in your mind are numbers that you cannot break down and numbers that you can break down. When we talk about breaking down, what I'm really saying is that you can raise. And so the first number that we can't break down is 2. And because that means, nothing raised to the power is 2 except for 2. But that doesn't do me any good. So I don't want to waste my time with that. The next number that I cannot break down is 3. Well, guess what? 4 can be broken down because 4 is 2 squared. Then I have a 5, which cannot be broken down. And then I have a 6, which cannot be broken down. And then I have a 7. And then I have an 8. Ooh, but when I get to 9, guess what? That can be broken down because that's 3. It's 3 squared. Well, 10 cannot be. What's the pattern that you're seeing? And it's going to continue. The next number I'm going to get is 16. And then 25. And then 30. What do you notice about the numbers in the can?
They're perfect squares.
Yeah, they're perfect squares. Okay, and so what's going to happen is, and then of course this continues. So when we are given a problem, and you look at these numbers, and you're trying to decide whether you can or can't, look for a perfect square. And if it's not a perfect square, then it probably cannot be. So in this case, we're going to start on the left-hand side. And we're going to say, hey, look, there's the number 9. It's a perfect square. What does 9 break down to?
3 squared.
Okay, so watch what's going to happen. We're going to do 3 squared. We're going to put in parentheses. Now, that only takes care of the 9. This is still being raised to the 2x minus 5. That doesn't just magically go away. Come on, 2x minus 5. Now, equal sign. Now, you're going to notice that 27 is not a perfect square, but that's okay because we have a base. We have a base 3. And so I need to know, can I take the number 3, raise it to a power, and you already know the answer to this because we just did it, and get 27. 3 to the what gives me 27 here?
Third.
Yeah. And so 27 becomes 3 to the third. But again, this stuff's still there. It doesn't go anywhere because you haven't done anything with it. Okay. And so now we're looking at this and we say, okay, well, we have the same bases. But now you're going to notice something. This is the first problem where, well, I guess it's not the first problem, but this is a problem where I have a power to a power. When we studied exponents way, way back, what did we do with powers that were being raised to powers? How did we condense them? Didn't we take this and multiply? Remember how we did that? Well, guess what? That's still not going away. So the base 3's are fine. I don't need those anymore. I'm going to have 2 times 2x minus 5 equals 3 times x minus 2. Now the hard part's done. The hard part was this step right here. What are your thoughts so far? Okay, and so now we just have to go ahead and we have to solve this equation. So let's do it. So 2 times 2x is 4x, and 2 minus 5 is 10, equals sign. 3 times x is 3x, and 3 minus 2 is negative 6. And then I'll subtract 3x, and I'll get x minus 10 equals 6. Then I'm going to add 10. Wait, something's happened. What have I done? What have I done?
Wait, why do you have a 2 in front of the very first? Why does it say 2 parentheses 2x minus 5 instead of 3?
Only
Oh,
2.
hold on. I gotta back up for a second. I've done something crazy. We said, let me get my eraser out because I've mucked everything up. I can't see. We said that 9 was 3 squared. That's okay. Yeah, if you see what I've done, just tell me. Your 6 should be negative. Thank you. Okay. Thank you. That's it. All right, I've miswritten this 6 right here. It's an easy fix. Thank you. This 6, instead of being positive 6, should be negative. I just missed the negative sign. We're good. Now, someone asked me, why do I have this? Is that what you said?
Yeah, why is it a 2 instead of a 3?
Because our bases are the 3, which I don't care about. I only care about the exponents. And in this particular one, we said it was 3 squared. So these are the exponents that are being multiplied.
Oh, okay.
It just so happened that over here it was 3 to the third. This could have been a 5 or a 6 or anything. It just happened to have been a 3. That's all.
Okay.
Okay, so now let me get back to where I was. So I'm adding 10. Thank you for finding that mistake. So I'm going to get x equals 4. And this is my answer. And now I'm done. All right, what do you think? So these problems are neat. I like these problems a lot. And they're going to help you when we move on to logs. Has anybody ever worked with logarithm functions before?
I feel like I've heard it, but I have no idea what it looks like.
Okay, that's good. I kind of like that because then you don't have, then you guys don't have, some people have, oh, no, you can't say that word. You can't say, no, you guys can't hate them, okay? I'm going to make you at least like them. All right, I promise. That's the goal here. So we're getting ourselves a really solid foundation so that in a couple of days, when we see logs, you're not going to say that terrible hate word, okay? I don't like that word. All right, let's do a couple more of these, and then we'll be done. And you guys can ask your questions. So let's take a look at number 4. Let's see. How about, okay, let's do this one. We're going to have 8 to the x minus 1 equals 1/2. Okay, now, earlier, just a minute ago, I had all these numbers over here, and I said, look for a square root. Well, I don't see a square root. And so here's what happens. Sometimes we don't have perfect squares, okay? But remember remember how I give you a square root list? What other kind of list did I give you?
Cubed root list?
Yes. Okay, so we can look for square roots or cube roots. And so in this particular case, my base is the number 8. Over here, my base is the number 1/2. Well, they're obviously not the same. And 1/2 is a fraction, and I'm going to have a real hard time turning 8 into 1/2. But is there a way that I could rewrite this so that a base raised to a number equals 8, and then that same base raised to a number would equal 1/2? So start thinking. Can I take a number and raise it to a power and get 8? These are things that we kind of have to memorize some of this stuff so we don't spend 8 hours typing things into our calculator. Yeah, number 2. So if I put 2 to the third, that's going to give me 8. Okay, cool. Now, yeah, you're right. So over here, I need that same base to be 2. But the number that I need to put into this box is going to have to be what? Because I'm going from a whole number to a fraction. And when we did these exponents, it has to be a negative. And so in this case, it's going to be a -1. Well, that looks like a 7. -1. So pause. I'm going to pause for a second. This is the most important thing you're going to do. This step right here. Any issues with it? Because we have to be able to do this. Otherwise, we're not going to solve these problems. So then what's going to happen is we're going to say, okay, well, this number 8 is going to turn into 2 to the 3rd, but then this x minus 1 is still totally there. And this number 1/2 is going to turn into 2 to the -1. And so now I say, okay, do I have the same base? Yeah, it happens to be a 2. So I'm just going to color over it a little bit so we don't look at it. And then I say, okay, well, here are the exponents. And since there are 2 of them, they have to be multiplied. And here's the exponent, and there's only 1. And so this is going to become 3 times x minus 1 equals -1. And then now, here I go. This is it. 3 times x, 3x. 3 minus 1, -3 equals -1. And then I add 3 to both sides, and I get that 3x equals +2. And then I divide, by 3, and I get x equals 2/3, and now I'm done. So even when we see these fractions, okay, and even when we see numbers that aren't perfect squares, we have to just pause and say, okay, well, draw this out, draw these blank spots, and ask yourselves, what numbers do I have to fill these with for this to be true? Okay, that's actually a really good plan for you if you have to do that. Do it. All right, so what are your thoughts on this one? All right, I want to show you one more, okay? And then if you have other questions, I have more examples, but I want to show you one more, another type of problem that you're going to see. So let me see which one that is. Okay, so let's do this one, and it'll be the last one unless we need to do more. Number 5, what if I have 2/3 as a fraction raised to the x power equals 9/4? Okay, so now we have 2 fractions. Okay, so I'm going to look at this. I'm going to say, well, over here, this base is 2/3, and he's pretty much just it. That's pretty much it. I can't really, do anything. So then I'm going to look over here. What do I recognize about each of these numbers? Not necessarily as the fraction, but as each separate number. 9 and 4.
Square roots.
Perfect.
Yes, they're both perfect squares. Okay. Can I flip the first fraction? 2 to the -1. Okay, yeah, I could do that, but I'm going to mainly focus on the second fraction because not only am I going to have to flip it somehow, but I'm going to have to square root it. Okay, so bear with me. So I'm going to have 2/3 to the x. I'm not going to change that. I know that 9 is just 3 squared. I also know that 4 is just 2 squared. Right here is the number 3 and 2. That's pretty darn close to what I need. So someone over here in the chat, actually in the chat, is asking me, can I flip these types of things? The answer is yes. And so here's what I want to do. I want to rewrite this as 3/2 squared. That's what I want to do first, which is super great, except 2/3 and 3/2 are not the same number. And so we've talked about exponents enough that if I need to flip it, just like, remember we talked about our bookshelf? We said there was a top shelf and a bottom shelf. And if we want to flip it, we literally just pick it up and we scooch it. But if that happens, then we have to make one of the numbers negative. And so what I like to do is I like to take 3/2 and I like to flip it upside down. And so if I do that, what's going to have to happen to this +2? It's going to have to turn into what?
-2.
Yeah. And so then I say, okay, well, once I got that far, now don't I have the same basis? Aren't these guys the same? Yeah. Which means I can get rid of them. And bam, with just a little bit of effort, I have an answer. All right, take that in. Excuse me. What are our thoughts? So I think that I have showed you all the types of problems that you're going to be seeing. And so we did the graphing, and we did the solving of the elementary exponential equations. So what are your thoughts? Because I'm done.
I feel like I'm good, but I'm nervous about if Hawks will have more complicated issues.
So being very straightforward with you, last night and today before class, I went into Hawks and I did the homework section, and I did it twice actually. Once for these notes, so these problems literally came right out of Hux, and then once for the YouTube video that I make and post for and just an extra set of homework help. And the problems that we've looked at and the problems that I present to you in that particular video, if you decide to watch it, I can't fathom the problems being any more difficult, so to speak. Okay, now, this fraction might be a different number, maybe 8 over something, I don't know. But as far as the difficulty level goes, I think that if this is good, if you're good on this, then you're going to be good on Hawks. Because again, I swear to you, I went in Hawks this morning, I pulled these problems out, I made these notes. I showed them to you today. That's it. That's where I get my notes.
Okay.
Okay, so and you guys know, especially now that we're online, I am all about the prize. I got my eyes on the prize. Right now, the prize is getting you through this Hawks stuff, and that's what I'm trying to do. So you've seen it. Maybe you go work on it. I'm also in the middle of making the 4.1/4.2 homework for Blackboard. I just, you guys, I'm sure it happens. You get sidetracked. You get a little lazy because you're just home all day. I'm the same way. Okay, I'm like, I'm gonna do homework, and then I'm like, nah, I'd rather not. So what happens? All right, anything else anybody wants to ask or tell me right now before you go? Because I'm done. Ooh, hey, you guys want to see a puppy?
Sure.
Okay, so give me a second, Shelby. Let me stop the share here. And then, can you turn your on? There we go. Let's see if I can make you big. I don't know if I can or not. Haha, there we go. Can you guys see her?
Yeah.
Tell us about her.
Oh my goodness, I heard about her on work study and I finally get to see her.
Uh-oh. Oh no, what happened? Oh, she's back. Shelby, can you hear us? Can you tell us about her? I don't know if she can hear me or not. Anyway, guys, this is Shelby's puppy, Sage. She just got her 3 or 4 days ago.
I work with Shelby for the same on-campus work job, and
Yeah.
she's been talking about her, but I haven't gotten to see her.
Aw. Yeah, I've heard a lot about her too because she keeps updating me and I can't wait to see her. Now technology, it doesn't work when you want it to work. We'll give her a sec. You guys don't have to wait. You're more than welcome to exit. I don't know. I can't seem to see. I don't know. Come here, Spark.
It